Hello students, in this video, I will highlight a few important things that you should know about factorial design. So stay tuned. Here is the outline of today's tutorial. First, I will talk about what is factorial design. Secondly, I will discuss why we use factorial design in the experimental setting. Third, I'll provide some examples of experiments using one factor at a time and factorial design. The fourth topic will be related terminologies. The fifth topic will be different effects related to factorial design. And at the end of this tutorial, I will give some problems and we'll have a look at how to solve the problems. What is a factorial design? By definition, it is a design that a researcher uses to investigate the effect that two or more categorical variables, or known as independent variables, have on the third continuous variable, which is also known as a dependent variable. Suppose we want to measure the change of cell concentration, let's say E. coli, which is a gram-negative bacterium, and we want to study the effects of three different factors on the growth of E. coli. Let's say we name the factors as factor 1 as pH, factor 2 as the temperature, and factor 3 as glucose concentration. So what we do is that we manipulate all the factors and we measure the cell growth during the experiment at the same time. So that is how a factorial design experiment is performed. Traditionally, we have what we call one factor at a time approach, which only investigates the effect of one independent variable on the dependent variable at one time. Suppose we still refer to the same experiment, but in this case, we just focus on one factor. So instead of having three factors just now, we just focus on one factor, let's say temperature. So during the experiment, we just manipulate the temperature and we measure the cell growth of the E. coli. So that's the big difference between factorial design and one factor at a time approach. Looking at the difference between factorial design and one factor at a time approach, there are reasons why in some situations we may need to use factorial design method. Here are some reasons. In reality, a typical process has many variables that have many simultaneous effects. For example, the growth of bacteria depends on many factors such as aeration, temperature, pH, sugar, and etc., and not just only one factor. So it means that the process could be well understood if we study more than one factor at a time in order to understand the actual nature of the process. Secondly, it is a systematic approach that optimizes the number of experiments. This is due to the number of factors that is more than the one factor at a time approach. So it means that we can organize more data and also more factors at one time. The third point, it provides a quantitative and qualitative means to investigate variable responses. This is quite related to the second point just now. And finally, it is more beneficial than one factor at a time approach in terms of the results produced, which is more, and also the reduction of time taken in order to perform the experiment, because more factors are studied at the same time compared to only one factor in the one factor at a time approach. Now let's move on to some examples of one factor at a time approach and also factorial design approach. First, let's have a look at one factor at a time approach. Here are some examples of the experiments. The first example is the effect of temperature on Pichia pastoris growth, where in this case temperature is the only factor or variable, and Pichia pastoris growth is the response that we would like to measure during the experiment. Suppose we have three different levels of temperature, 30, 40, and 50. And for each value of the temperature here, we would like to get the response, that is the Pichia pastoris concentration. In the second example, The experiment is on the effect of pH on Pichia pastoris. So instead of the temperature just now, pH is the only factor or variable that we would like to manipulate in this experiment. Suppose we have 4 levels of pH, 5, 6, 7, 8. The objective is the same, that is, we want to measure the cell concentration of Pichia pastoris at different pH values. The third example deals with the effect of glucose concentration on Pichia pastoris growth. Glucose concentration is the only factor or variable. Here are some examples of the levels of glucose concentration, and we would like to know how much the concentration of Pichia pastoris will be affected by different levels of glucose concentration. So these are examples of one factor at a time approach. Now let's have a look at some example of experiments using factorial design. The first example here is the effect of temperature and pH on Pichia pastoris growth. There are two factors to be studied simultaneously in this experiment, namely temperature and pH, and the response is the Pichia pastoris growth. So this experiment is called two-way factorial design. In the second example here, we add another one factor, that is aeration. So altogether there are three factors, namely temperature, pH, and aeration. The response is still the same, the Pichia pastoris growth. So this experiment is called three-way factorial design because it has three factors. And in the third example here, there are four factors, namely temperature, pH, nitrogen, and glucose concentration. The response is still Pichia pastoris growth. So it is called four-way factorial design because it has four factors. So by definition, factorial design is an approach that investigates the effect of two or more variables. So the minimum number of factors is 2, and it can be more than that, either 3, 4, 5, and so on. But the more factors to be investigated, the more complex the experiments will be. Now let's have a look at one example of detailed information about the factorial design experiment. So in this case, we talk about two-way factorial design, whereby there are three levels of temperature, 30, 40, and 50 degrees, and also there are three levels of pH, namely 3, 4, and 5. So altogether, the number of experiments or treatments to be conducted will be 3 times 3, that is 9. So at the end, we expect to get 9 responses for all of these experiments conducted at different pH and temperature values. This is how we present the data in terms of the graph. So we plot the y-axis as the response, that is the Pichia pastoris cell concentration in this case. For the x-axis, we can either choose temperature or pH, but in this case we choose temperature. But it's important for you to know that we can also plot pH in this case as the x-axis. So let's say we choose temperature. You can see that we plot from 30 to 50 degrees Celsius because those are the values that we investigate in this experiment. And there are three different profiles given by different pH values. So that differentiates the graph for each of the pH value. So that's how we present the two-way factorial design data in this case. The next topic is related terminologies. Let's have a look at some terminologies that we will refer when we talk about factorial design. The first terminology is independent variable. It is defined as variable or factor that is manipulated or varied, and it is plotted on x-axis. For example, in this case, we have two factors or two independent variables, namely temperature and pH. and you can see that temperature is plotted on the x-axis, but as I mentioned just now, you can also plot pH on the x-axis. The second terminology is correlational variable, which is a dependent variable or non-manipulated variable or factor measured by the investigator. It is also called response, and it is plotted on the y-axis. So this is the dependent variable in this example, which is P. pasteur's cell concentration. The third terminology is level, which is defined as the number of values of the factor to be tested. There are two levels, namely low value and high value. Low value refers to the lowest value to be tested, whereas high value refers to the highest value to be tested. So in this example, for temperature, there are three levels, 30, 40, and 50. The low value is 30 and the high value is 50. For the pH, there are also three levels. The low value is 3 and the high value is 5. The next term is two-way factorial design. It means that the two indicates there are two factors to be studied simultaneously. We can also have three-way factorial design, which indicates there are three factors to be studied simultaneously. And if we have 4 and 5, then we can say 4-way, 5-way, and so on. The next term is treatment, which is defined as specific combinations of factor levels. For example, in this case, the number of levels for the two factors are 3, respectively. So the number of treatment is equal to 3 times 3, that is equal to 9. Factorial designs can also refer to as the following format. For example, 2 times 2, 2 times 3, 3 times 4, and etc. But what does these numbers mean? For example, if we have 2 times 3, the first letter refers to the number of levels of the first factor, or factor 1. So in this case, factor 1 has 2 levels. The second number here refers to the number of levels of factor 2, or in other words, factor 2 has 3 levels. So the number of numerals indicates the number of categorical variables. So in this case, the number of numerals are 2 because they are 2 and 3. The actual value of the numeral indicates the number of levels the categorical variable has. The actual value here refers to 2 and 3. So 2 means there are 2 levels, 3 means there are 3 levels. Let's say we have 3 times 4 factorial design. That means that there are 2 factors because the number of numerals are 2. And the first factor has 3 levels and the second factor has 4 levels. Let's say this is an example of a factorial design with 3 levels for each of the factors. This design can be referred to as 3 times 3 design because it has 3 levels for each of the factor. The next topic will be different effects. In factorial design, there are 2 types of effect. The first one is main effect, which is defined as the unique effect that one categorical variable has on the dependent variable, regardless of the level of the other categorical variable. The second type of effect is interaction effect. It occurs when the effect that one categorical variable has on the dependent variable varies, depending on the level of the other categorical variable between factors and not the levels. So, how to know whether or not an interaction effect exists is based on the profiles of the data. If the lines of the dependent variables are not parallel, then an interaction effect is present. So we'll have a look at this in the following examples later. All effects in a factorial design are independent. So meaning to say that each of the factor, it will have an effect or a description of how the behavior of the profile. For example, the presence of a main effect has no influence on the other main effects or any interaction effects and vice versa. A null outcome situation is when the outcome of the experiment is the same, regardless of how the levels within your experiment were varied. Meaning to say that, in other words, a null outcome will be there is no effect of the factors, regardless of how you manipulate or vary the factors. Let's have a look at this example. In this example, there are two factors to be manipulated, and we want to measure the response, that is the P. pasteur's cell concentration. So how to describe main effects and how to describe the interaction effects. So for the main effects, we have to describe how each of the factor behaves and how it will give the change in the response. So factor 1 is the pH. You can see that for all the pH values, you can see the trend is increasing. So we can say that as the pH increases from 3 to 5, the cell concentration of P. pasteur's also increases. For the second factor, that is temperature, you can also see that as the temperature increases from 30 to 50 degrees Celsius, the cell concentration of P. pasteur's also increases. So that explains the main effects of the two factors in this example. How about the interaction effect? You can see that all of the profiles given by the profile of pH 3, 4, and 5, they are parallel. So meaning to say that there is no interaction effects because the profiles are all parallel. So that explains how we're gonna describe the effects, the main effect of this profile, and also how to interpret or to determine whether or not there is an interaction effect. The second example is given as follows. You can see that one profile is not parallel anymore, which is the profile of pH 5, whereas the other two profiles are still parallel, pH 3 and pH 4. So how to describe the main effects and the interaction effects of this graph? So since there is an interaction, it's very hard for us to separate one factor from another. So in order to describe both effects, we can just combine the two and explain it in two descriptions. For example, the first description will be about pH 3 and pH 4 since it presents the same trend. So we can say that as the pH increases from pH 3 to 4, the cell concentration of P. pasteur's also increases. But for pH 5, since the trend is different from the other pH values, so we have to describe the trend separately. What we can say here, at pH 5, the cell concentration decreases when the temperature is increased from 30 to 50 degrees Celsius. So that explains the main and interaction effects of the two factors in this example. The third example is given as follows. Now you can see that all the profiles of pH 3, 4, and 5, they are horizontal, but they are parallel. So how to describe the main effects and the interaction effects of this example? For the main effect, we can describe the factors separately. For factor 1, as the pH increases from 3 to 5, the cell concentration also increases. And for the second factor, As the temperature increases from 30 to 50 degrees Celsius, you can see that there is no change of the cell concentration of P. pasteurus. So that's why all of the profiles are horizontal. It's the same value. How about the interaction effects? So you can see that all of the profiles are parallel. So meaning to say that there is no interaction effect between the two factors in this example. Factorial design can also be presented in terms of an equation. This is an example of a model for two-factor factorial design. So what are the things that need to be incorporated into the model? You can see here the equation includes the main effect of factor A, the main effect of factor B, and also the interaction effect of the two factors. Please take note that the equation or model varies from one experiment or design to another. So if you have three factors, means that you have to incorporate the main effect of factor 1, factor 2, and factor 3, and also their interaction effects. And the same thing goes to 4 factors, 5 factors, and so on. Before we wrap up, let's have some exercises. Suppose we have this problem. A biotechnologist would like to study the production of lacase, an enzyme used for wastewater treatment, in recombinant Pichia pasteurus. He or she decided to test the effect of glucose concentration on lacase activity at 10, 20, and 30 gram per liter. He or she is also interested to know the effect of initial culture pH, namely pH 3 and pH 4, on the lacase activity. Let's have a look at how we're going to answer the questions here. The first question is, what is the null hypothesis of this study? So the answers will be, glucose concentration has no effect on lacase activity and initial culture pH has no effect on lacase activity. So we have to mention the conditions, the null conditions for all the factors involved. So since there are two factors in this experiment, so we have to mention both of them. The second question asks us how many factors are involved in this study. So obviously there are two factors. The third question, name all the independent factors. They are glucose concentration and initial culture pH. The fourth question, what is the response in this experiment? Response is normally the thing that we want to measure or the dependent variable. So in this experiment, it is the lacase activity. The fifth question, how many levels of the factors that the biotechnologist plan to set in his or her experiment? So for the glucose concentration, there are 3 levels, and for the initial culture pH, there are 2 levels. How many treatments are there in this experiment? The number of treatments is equal to the multiplication of the number of levels of the factors involved. So in this experiment, the number of treatment is 3 times 2, which is equal to 6. The seventh question, is this study a 2 times 3, 3 times 3, or 2 times 2 factorial design? There are two answers. Is either 3 times 2 or 2 times 3 factorial design. The reason is, if we assume glucose concentration, which has 3 levels as the first factor, and the pH as the second factor, so it will be 3 times 2 factorial design. But if we assume the culture pH as the first factor and the glucose concentration, which has 3 levels, as the second factor, then it will be 2 times 3 factorial design. So that answers all the questions here. The last question is given as follows. Based on the graph below, describe the main and interaction effects. Before we go into the solution, let's analyze the graph. You can see that the profile given by pH 3 and pH 4, they are not parallel. So from here we know that there is an interaction between pH and glucose concentration. So if there is an interaction, we can't exclude one factor from the other when we describe the demand and interaction effects. So how to answer this question? It can be described as follows. At pH 3, as the glucose concentration increases from 10 to 30 gram per liter, the lacase activity also increases. The second effect can be described as at pH 4, there is no change of lacase activity when the glucose concentration is increased from 10 to 30 gram per liter. So that answers the question in this problem. To summarize what we have learned today, first we talk about what is factorial design. Next, we discuss why we use factorial design. And then we go through some example of experiments using one factor at a time and factorial design. Then we also discuss some terminologies related to factorial design. Next, we talk about different effects of factorial design, namely main effects and interaction effects. And finally, we go through some exercises and we solve some problems in the exercises. That's all for today. Thank you very much for watching. This video is brought to you by No Statistics, No Talk. Please subscribe on YouTube channel for more video tutorials on statistics. Stay safe and have a nice day.